Let's go ahead and graph one of these functions. The first thing we're going to do is we're going to find some intercepts because that'll give us some footholds. Then we can use the end behavior to shape the rest of our graph. So let's find the x-intercepts first. So we're going to set f of x equal to 0. And this is a part where I'm not actually going to show this, but I would then graph this and find that it looks as though x equals 1 is one of our zeros. So I'm going to confirm that using synthetic division. Again, this is a third degree polynomial. So once I divide by, really remember I'm dividing by the factor x minus 1. I'm going to have a second degree polynomial, which I should be able to factor, use the quadratic formula. And there we go. I've confirmed that this is in fact a factor or a 0. So I can rewrite my function here. F of x is just equal to x minus 1, that factor I just found. And then here I have 2x squared plus 7x plus 6. I know that I can then factor this next piece here into 2x plus 3 times x plus 2. And from there, I can find the remaining zeros by, again, setting f of x equal to 0 and setting each of the factors equal to 0 and solving. Now, I will notice these all have odd multiplicity, and I'll make a note of that so I don't forget later. And now I'll go ahead and find my y-intercept. Well, we find the y-intercept by setting x equal to 0. So the y-intercept is just going to be when we have f of 0. So we wind up with the additional point, 0, negative 6. And now I just have to figure out how my graph is going to behave at its ends. So first I'm going to look at its left end behavior, or as x approaches negative infinity. So I'm going to look at the limit as x approaches negative infinity of f of x. And I know that'll just be equal to the big term as x gets real small. And again, I just care about the fact that 2 is positive, and that in this case, since I'm going to the left, x will be negative. So I end up with a positive times a negative, which is of course negative. So I know that my left end behavior is I'm going to be going down. Now I'll find my right end behavior. So that would of course be the limit as x approaches positive infinity. In this case, I end up with a positive value. So I know that f of x will be traveling up as I go to the right. And now, if you haven't quite figured it out yet, we're just going to kind of use all this information to graph our function. So I'm going to plot all of my zeros. And now I'll plot my y-intercept. And I'll go ahead and fill in my end behavior. So I know that as I travel to the left, I'm going to be going down. And as I travel to the right, I'm going to be going up. And in between, I know that all of these have an odd multiplicity, so I can go through and I'm going to pass through each time. And you'll notice that when I was doing this part in the middle here, I didn't end up with any contradictions. I knew that I was supposed to pass through all of my x-intercepts. And I knew that I was supposed to travel down in this direction and up in this direction, and I had to pass through that point there. Well, putting all these things together, nothing contradicted itself, so I can feel fairly confident I got the right answer. Now, one additional thing that I didn't do was it would probably make sense to just plot some points. Now, I would likely plot one point that was in between these two critical values. So I might plot, like negative 1 3/4. And then maybe another one that at negative 1 and one more at like 1/2. I feel pretty confident in my graph, and I don't want this video to be too long, so I'm not going to do that. However, you can see that by filling in those values, we'd likely get a slightly more accurate graph. That is how you graph a polynomial function.